welcome to this video on linear laws. Now, from about year 7 onwards, you will be aware of the fact that in order to plot a graph, you're going to use the equation y equals mx plus c. You know, fairly standard equation, everybody knows it, everybody's happy using it. You'll probably know how to rearrange equations in order to put it into that form. Now, this is where it gets more fun. Now we're going to take a second kind of equation. We're going to take y equals ax squared plus b. Now, all of a sudden you're probably having a bit of a panic. How on earth do you deal with that? The answer, my friends, is remarkably simple. Now, we're going to draw out y equals mx plus c again, only slightly differently. As you can see, we've done a capital Y and a capital X. This is to kind of denote what we're using the terms y and x, but y and x don't necessarily mean y and x. I'll explain what I mean now. As you can see, we've made y and y, a is m, x squared is x, and c is b. So we'd actually write this as big Y, which equals y, big X, which is equal to x squared. So therefore it's y equals m big X plus c, or plus b in this case. Now what this means is that we can still plot a linear graph. We can plot a linear graph of y against x squared. Now this is good because it means that we can see relationships in a linear form, which often means it's much easier to draw lines of best fit, but also to figure out gradients and y-intercepts. Well, not so much y-intercepts because where it crosses the y-axis, but you know what I mean. Now, I'm not going to go into huge amounts of detail on how to find the gradient and intercept of lines, because I'm assuming by this point many of you will already know how to do it, and therefore I kind of see no reason to go through everything with you again. But what I am going to do is take another example and explain how you would deal with it. We're going to take 1 over x plus 1 over y equals a. Now obviously we want to get this into the form y equals mx plus c, big Y, big X. Now the way in which we do this is very simple. We rearrange it so we've got y on one side and x on the other. So it's 1 over y equals minus 1 over x plus a. Now in this case we've still made it a y equals mx plus c form, only y is equal to 1 over y and x is equal to x is equal to 1 over x. Now all this means is that when you have your points, in order to convert them into this form, for example, you need to do 1 over your y, 1 over your x, and in the other one all you do is you square your x values and you plot that against your y. You just need to adapt the values you've got to fit this form and you will get a straight line. Now the other type I'm going to go through, I'm not going to cover logarithms in this section, and my reason for doing so is because I would prefer to cover logarithms at a later date when I'll do a whole set of videos on logarithms to go through them, but I'll go through that in its own mini video. This is primarily to do with stuff that is easily manipulated. The other example that I'm going to use is y cubed equals ax squared plus bx. Now obviously you can't really do a lot about the y cubed, but you notice there's an x squared and a bx. Now obviously you only want one power of x on this side to make it into the form y equals mx plus c. So this is what we do. We divide it by x, so it's y cubed over x equals ax plus b. And there we have a form that fits the equation. So we can write, so this is equal to y equals mx plus c. So y is equal to y cubed over x, and x is just equal to x. So when we're plotting this, all we're doing is we're going to be plotting x on the x-axis and y cubed over x on the other axis. And this should yield us a straight line, something along the lines of, I don't know, that. But it may not be that shape, but it's still a straight line. And then from that you can obviously work out the gradient and working out the y-intercept. Thank you very much for listening. I'll catch you later at some point.